Good morning, students. Today I am explaining about the capacitors. So, like resistors, inductors, capacitor also a device. So, what is capacitor? Capacitor is a device which is used to store electric field energy. Electric field energy. That means electric field energy, or in some books we are writing stored to store electric charge. Charge produces the electric field. Therefore, this electrical field will, in this electrical field there is energy will be stored. This potential energy converted into electrical field energy. Okay, so that in different books different terminology using regarding the capacitors. But what are the types of the capacitors? Types of the capacitors are many there: cylindrical, spherical, parallel plate capacitors, and so on. But now I am going to explain only parallel plate capacitor. Parallel plate capacitor. So what is the meaning of parallel plate capacitor? So according to the name, there are two parallel plates, metallic parallel plates, which are separated at a distance d. Each plate area is a, and the in between them there is a non-conducting medium, means air or dielectric material or any insulating material will be there. Okay, this is the description of the plates only. Okay, when these two plates are connected to a battery of potential V let, and when switch is closed here, what happens? So according to, but here gap there circuit is not completed here like electrical circuit. Though, okay, when the switch is closes here, the charges will start to flowing from negative to, okay, positive. Like the electrons are flowing like this. As the electrons are flowing here, okay, here in this plate negative charge will be accumulated, but inside there are electrons also there. These electrons will repulse the what are the electrons stored here. Therefore, against this we have to do some external work to store this energy, to store this charge. And again, because of the induction, here there is a positive charge will be accumulates or stored or settled. Anyhow, after some period of the time, right, there is a positive charge on positive plate, the left plate, and there is a negative charge on right plate. We will see, right? So, but in some books we are writing there is a charge will be flowing like this, positive charge here by the induction, negative charge like this. Okay. Anyhow, this is the small mechanism involved here. So, in this capacitor, right? Suppose after charging this, after some time, this potential energy will be converted into electrostatic potential energy, sorry, electric field energy. So when battery is disconnected, this electric field energy again converted into potential energy. So that's why this is the meaning of the charging and discharging of the capacitors, which are used in many practical purposes. What is mean capacitor? Capacitance. Capacitance. Capacitor we know. What is capacitance? Capacitor is a noun. This is a adjective. But anyhow, what is the meaning of this definition of means? It is ability or capability. But here we are using the word capability. So it is the capability of a capacitor to store the electric field energy is called capacitance. That means how we will define this one? The amount of the charge is stored on the plates, which is directly proportional to the amount of the potential difference across the battery. Okay, this charge equal to some constant times potential difference. This constant is called capacitance. That's why the capacitance SI unit is 1 coulomb per 1 volt is called 1 farad. SI unit is 1 farad, which will be measured in microfarads and millifarads. Okay, very small quantity only will measured in the electronic circuits. Okay, now, but is this capacitance will depends upon the charge and potential? No. But on which factor which will depends? It will be depends on the geometrical property of the this device. What are the geometrical properties? Area and distance between them and medium. That means permittivity of the free space. Okay, suppose space we are using means epsilon naught A by D. Okay, this is the capacitance of a parallel plate capacitor. Okay, but this is a but how we will define or derive this parallel plate capacitance of a capacitor, right? So already we know, again once again I will briefly, this is positive, this is negative, right? Here because of the from positive to negative electrical field will be exist. Okay, on every perpendicular line according to equipotential surface concept, at a distance d from this plate to this plate, what is the potential here will exist here? V is equal to electrical field times distance. Okay, at this distance potential difference is V. Therefore from this one we will define that, right? So to define this one, again we know that in the previous Gauss law, what is the electrical field of a one that is charged plate? That is, we know in the previous class, E1 is equal to sigma by epsilon naught, 2 epsilon naught. So similarly second plate also sigma by E2 also sigma by 2 epsilon naught. Therefore total electrical field is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon means just sigma by epsilon naught. Means 1 by 2 plus 1 by 2 almost 1. So where sigma is called charge per unit area. This is surface charge density. Because of the surface we are using here, the word we are using surface charge density. Therefore, this C value, C we know, sigma we know, E we know. By substituting all, now we will derive the this capacitance of a parallel plate capacitor. So from this formula, what is V? V is equal to Q by C. And what is E? Total electrical field, sigma by epsilon naught into D. In the second step, Q by C is equal to sigma is Q by A into epsilon naught, same I taken D. Here Q cancel, say C is equal to epsilon naught A coming here, okay, C coming here, D coming down. Therefore epsilon naught A by D. This is the capacitance of a parallel plate capacitor. This is very important for both state and central syllabus CBSE. Now, in the second session, we should know the equivalent capacitance of a parallel plate capacitor and series capacitor combination. Okay. After that, some models, shortcut methods we should know. Now, what is the equivalent capacitance of a parallel plate capacitor? Parallel plate capacitors means combination of, what is the combination we are, which combination? Parallel plate combination we are using. Okay, how can we identify whether it is a series or parallel? Suppose all positive plates of the two capacitors, okay, connected to one end, all negative plates, this is plus Q, negative plates of the two capacitors are connected to a common point. Such combination is called parallel plates capacitor. Then which is connected to a battery. These common 2 points are connected to the battery of potential led to V. Now here we should understand, let when the switch is closes here, charge will be flowing here. Charge can be divided at point E according to Kirchhoff current law, Q1 and Q2, which are according to the capacitance C1 and C2, right? But again about the potential, either the potential will be same across the two capacitors or which is different. As these two capacitors are connected in parallel to the battery, therefore the potential across the two capacitors are same. Okay. So because of this, we will find the equivalent capacitance. How? Here which is same, potential will be same. So V is equal to same. Which is different? Charge is equal to different. This different charge can be written as Q is equal to sum of Q1 plus Q2 at the point to A. Now we know what is charge Q. Previously we know that Q is equal to C. Okay, V is equal to what is Q1? C1V plus C2V. Why? Because V is same in the three, means in the two capacitors, and we CE is the effective capacitance of the combination. This V get cancelled, therefore CE is equal to C1 plus C2 in case of parallel combination. This is also very important. And what is the series combination? Series combination. Sorry. In series combination, how can we identify whether this combination is series or parallel? First, we will focus on, let the positive plate and this is the negative plate of the first two capacitors of the capacitance C1. Similarly, negative plate will be connected to positive plate of the second following capacitor of the capacitance C2. And again, obviously, second plate of the second capacitor is minus, and so on. If these combinations will be connected to a common point, this type of combination called series combination. Means first negative, second positive, second negative, third positive, third negative, fourth positive, and so on like this. Here also, when switch is closes, charge can be flowing. This charge will be same throughout the circuit. Why? Because in series, all of you know in the electrical circuits, but which is different here, the potential across capacitor C1 is V1, potential drop across C2 is V2. Okay, as these two devices are in series, the potential drops will be different, but which will be same? Charge will be same. Which will be different? Potential is equal to different. This different quantity can be written as sum of the two potentials. Therefore, V we know already, Q by C is equal to V1 is equal to same charge but capacitance C1, same charge but capacitance C2. Q get cancelled, 1 by C is equal to 1 by C1 plus 1 by C2. Okay, this is the effective capacitance of a series combination, which also can be written as C is equal to C1 C2 by C1 plus C2. Okay, for example, C1 C2s are 4 farads there. Then what is the equivalent capacitance? 4 into 4 by 4 plus 4 means just 4 by 2, 2 coming. 6 means 6 by 2, like this. Okay, that models we will see in the effective capacitance in many models, right? Now, in the next session, in this lesson, we will go through the, so what are the concepts we understand in this class period of the class now? What is capacitor? What is capacitance? What is the capacitance, parallel plate capacitance formula? And what are the factors the capacitance will be depends. Next, what is the parallel combination, what is series combination, this we will know. Now based on all this, we will do some problems now. Very short fraction of the seconds. Okay, how we will solve these problems with this parallel and series techniques. All these parallel plates combination problems only now we are going to do. Okay, with the Kirchhoff laws, some applications, the Kirchhoff laws and parallel and series combination problems will be different. Now without Kirchhoff laws, okay, we are finding the only effective combination of the effective capacitance of the combination of the plates. This is the class today, right? Now we will do first problem start. How many plates there here? 4 plates there. 1, 2, 3, 4. But in problems sometimes they are giving like this also. These two plates are connected to the battery of higher potential and lower potential, and again these outer plates are connected to a common potential. So first students should understand here, this plate is V potential, this lower plate is 0 potential, upper two plates will be having common potential V. Now V is in combination with V dash, 0 also in combination with V dash. Therefore we can write V and 0, right? 0 will be in contact with V dash. V also in contact. That's why we can place V dash anywhere. No issue. Now V dash and V, one capacitor completed, and this is tick, not V, and V, okay, V over na 0 and 0 and V dash, 0 and V dash. This capacitor also completed, and V and 0, V and 0. This also completed. There are three capacitors of equal area, equal distance between them, and the medium is free space means epsilon naught. Let this data they are giving in the problems. Now, okay, how can we find the effective capacitance of this combination of the plates? Let all will be equal. This both are in series means already I told you effective V just to C by 2, and this C by 2 and C is in parallel. That's why C by 2 plus C. That means 3 by 2 C, which is effective capacitance of the combination. So CE is equal to 3 by 2 into epsilon naught A by D. This data they are giving means substitute and get the answer like this. Now let's see the another model 1, 2, 3, 4. Here also 4 plates there. 1, 2, 3, 4. 1, 2, 3, 4. But how they are connected? 1 and 3. This is higher potential. Last is lower potential, and these two are connected to a common potential. Let V 0 over, okay, means the students should understand every plate potential we will just consider. This 2 will be, let be V dash. Are you right without confusion? V dash and V dash. So all plates will have the potential. Enough. Now just whatever the positions you place, no issue, answers are coming. But in a short time means V is common to V dash. That's why V can be put here middle, V dash can be put here, and 0 can be, or lower potential will be put here. Now V dash and V, one capacitor completed. V and V dash, another capacitor completed, and V dash and 0, one capacitor completed. So there are three capacitors here also. Then answer also completed. C, these two are in parallel. Parallel means 2C. This 2C and C is in series. 2C into C by 3C. 2C plus C, 3C. CC cancel. Answer is 2/3 C, which is effective capacitance of these four plates. Within seconds we can just put the answer without using the very lengthy answers. Similarly, we use 5 plates models. How can we solve the 5 plates models? 1, 2, 3, 4, 5. This is third model. 1, 2, 3, 4, 5. But here 1 and 4 connected to a common potential, and this plate is the potential V given higher potential. This is lower potential given. That's it. But here this two potential, let V dash we know, but this plate potential we don't know. That's why let it be V double dash. So finally 4 plates potentials we know enough just to put in the circuit or get the answer finally. But V is in between V dash and V double dash. That's why we put here. One side you write V dash, another side write V double dash. Okay. Then this V again, V will be in contact with lower potential. Okay, that's why this is V double dash, this is V dash, because the space I am using, this is lower potential. That's it. Now V dash and V double dash, one potential, one capacitor, V dash and V double dash, not this one. Okay, this capacitor completed. V double dash and V double dash and V. Now this is completed. Now V and V dash, V and V dash, this also completed. Now V dash and 0, this also completed. Answer completed. C series, therefore C by 2. C by 2 and C parallel plus C, that is 3C by 2. 3C by 2 and C in series. 3C into C by 3 by 2 into C by 3 by 2 plus C. 5C by 2. 2 cancel, C cancel. Answer is 3 by 5 C. This is the effective capacitance of a 5 plates capacitors. 5 plates capacitors combination means in this combination 5 plates there, but capacitors how many there? 4 there. Obviously 4 means 3 capacitors, 5 means 4 capacitors, 6 means 5 capacitors, like this. This exam models we will see, and check one more example also finally. So in this also we will see how many plates? 5 plates. 1 2 3 4 5. 1 2 3 4 5. Here also 1 and 4 will be connected to a common potential. Let higher potential V given, and 3 and 5. 3 and 5, yes, 3 and 5 will be connected to a lower potential. That's it. But not like this in the problem. This is lower potential given, this is higher potential given, this is we don't know. But this, as these two are connected to the common, let it be V dash. That means here V dash and this also V dash for easy calculation purpose. And enough. This plate potential, every plate potential we don't know. This also V, this also V, this is V dash, this is V dash, this is 0. Fine. Now within seconds we will put the answer. But here also no issue. V dash is in between V and V. That's why V dash you put middle. V you put here. No problem. 0 you put here. Now start V dash to 0. 1 capacitor completed. 0 to V. 1 capacitor completed. And again V to V dash. V to V dash. 1 capacitor completed. And V dash to V. V dash to V. 1 more capacitor across this one come. Fine. So answer within seconds we will get the answer. CC, all are C's only, all measurements will be same. That's why CR parallel means 2C. 2C and C in series means 2C into C by 3C. 2C plus 3, 3C. Therefore CC cancel, 2C by 3. This 2C by 3, this combination is in parallel to C. So that's why this is 2C by 3 plus C. Just adding how much? 5 by 3 C. That's it. This is the equivalent capacitance of a combination of the any parallel plates. Within seconds we can solve, without using more time. So that's why today I am explaining you in the capacitor chapters. What are the flow I am using here? What is capacitor? What is definition? What is the capacitance? On which factor capacitance will depend? Depends. And what is the formula for capacitance? And after that I explain you what is the parallel plate capacitor and what is the capacitance of the parallel plate capacitors that we are using here. Next, what is the series combination, parallel combination, effective combination or effective capacitance of the series and parallel also I explain. Using all this I solved these models in very short methods. Thank you one and all. Bye.